So 3.1 we solved graphing, but now we're going to solve using these two other methods, substitution and elimination method. You have probably used these before in Algebra 1 last year, but the substitution method is where you substitute in a value for x or a value in for y. You'll always have two equations. So replace x for y variable.
We don't have all of those spaces.
Okay, well we'll go over it. We'll go over it, but just so you have it, replace x or y variable with equivalent expression. And then the elimination method is where you eliminate an x or y variable to solve for whatever is left, either the x or the y. Okay, so using the substitution method, you're going to... So with the substitution method, the first step is you're going to solve for one of the variables. So you either isolate the y variable in one of the equations that you're given, or you isolate the x variable in one of the equations. And then with that equation, x equals something, you will substitute that something, whatever x equals, into the second equation that you have. And then you'll use that to solve for the second variable. And then once you solve for the second variable, you'll repeat that step for the first variable, substituting what you have for the first variable. So let's do an example. So the first equation says x minus 2y equals 4, and then 2x minus 3y equals 1. We're going to use substitution method, so we're going to solve for one of the variables. Which one should we solve for? X, and which equation are we going to use? The first one. Okay, so we're going to solve for x using the first equation, so we're going to rewrite that equation. So x equals, we're going to add 2y to both sides, 4 plus 2y. And then we're going to take this value for x, and we're going to substitute it in for this x in the second equation. So we're going to rewrite now the second equation. We're going to say 2 times x, but we're not going to use the x. We're going to use something that's equivalent to x. So 2 times 4 plus 2y minus 3y equals 1. And then we're going to solve for y. So to solve for y, we'll use our order of operations. So take care of parentheses first. Okay, parentheses, you can't reduce that anymore, so we're going to do multiplication or division. So we get 8. We're going to distribute out the 4 plus 2y. So 8 plus 4y minus 3y equals 1. Combine our like terms. So we have 8 plus y equals 1. Isolate our variable, so subtract 8 from both sides. We get y equals -7. Okay, so now we have a y value. So we're going to go back to our original equation. And it doesn't really matter which one you use. You can use the first equation or the second equation, or you can use that new equation you wrote. I usually go back to one of the original equations just in case I made a mistake. So it's easy to see if I did make a mistake. So I'm going to use one of the original equations. So I'm going to substitute in my y value of -7. And I'm just going to use this first one, but it really doesn't matter which one you use. I'm going to say x minus 2 times -7 is equals 4, and now I can solve for x. So x plus 14 plus 4, subtract 14 from both sides, and I get x equals -10. Every single time after you solve for your two variables, go back to the original equations and make sure those two variables are actually a solution. Okay, so I'm going to plug in -7 for y and -10 for x into both original equations. So my first one, x minus 2y equals 4, I'm going to say -10 minus 2 times -7 equals 4. -10 plus 14 equals 4. I'm verifying to make sure that my solution is actually a solution for both equations. So the first one, yes, that x and y value matches. And I'm going to do the same thing for the second equation that I've given. So the second equation was 2x minus 3y equals 1. So 2 times -10. What was it, plus 3y? Minus 3y? 2 times -10 minus 3 times -7. Does that equal 1? -20 plus 21 equals 1. Yes, so my solution is actually a solution. You always want to go back and double check, just in case you made some computation error. Okay, for this next example, it says solve the linear system. Again, we're going to use substitution. So, which variable are we going to solve for?
Y.
We're going to solve for y. Are you going to use the first or second equation?
First.
Okay, so this y is already by itself, so all we have to do to solve for y for the first equation is add 3x to both sides. So rewrite your equation. Y equals 11 plus 3x. And then this value for y, 11 plus 3x, you can substitute into the second equation. So instead of saying 5x minus 2y, you're saying 5x minus 2 times 11 plus 3x. It's the same thing, 11 plus 3x is y, but this way you'll be able to solve for your x value. So 5x minus 2 times 11 plus 3x equals -16. And then again, you follow your order of operations. So 5x minus 22 minus 2 times 3x is 6x equals -16. You can combine your like terms. So you get -x minus 22 equals -16. And then add 22 to both sides. -x equals 6. And then you want just plain x, just positive x. So you have to divide by -1. And you should get x equals -6. Now again, it doesn't matter where you put this -6 for x, whether you put it into the first or the second equation, either one will help you solve y. I usually use the other equation, whichever one I didn't use first, but it's completely up to you. So I'm going to plug this into the first equation, -3 times -6 plus y. Substitute in -6 for x plus y equals 11. Then I get 18 plus y equals 11. And I subtract 18 from both sides. And I get y equals -7. Now again, to double check, take those values and plug them back into both original equations to make sure that your answer actually checks out. Is using the elimination method. So with the elimination method, you still have two equations, but you're eliminating one of the variables. And you're doing this by adding the two equations together. So you're always adding. So in order to eliminate, you want one of your terms to be the opposite, one of your x value or y value terms to be the opposite of the other one. Okay, so for example, like negative 4x plus something and 4x plus something. If I added these two equations together, my x values would be 0. I would have 0x, so it really would not matter what my x value is. So in order to get something like this, we need to multiply either the first or second equation by something. And when we multiply an entire equation, remember we multiply each individual term. So when you use the elimination method, first you're going to multiply an equation by some constant. Then you're going to add the two equations together. And then you're going to use the substitution method to solve still for the second variable. Okay, so here's an example where we're going to use the elimination method. Which variable should we eliminate? The x variable or the y variable?
I'll do that.
Yeah, how are we going to do that? Not by -2. Right, it's by +2. If we multiplied by -2, we would have negative 4x minus 4x, and when we added them together, it'd be negative 8x. So to eliminate, we're going to multiply the top equation by 2. So we have to multiply every term by 2. So 2x times 2 is 4x. Negative 3y times 2 is negative 6y. And that equals 1 times 2, which is 2. Then I always rewrite the second equation too, just so I can see them next to each other. And then you can add them together. And when I add these two equations, I get 0x, which is just 0, minus 4y equals 8. Then, just like you would solve for a single variable, we're going to isolate y by dividing both sides by -4. And we get y equals -2. Now the last step is to solve for our x variable. So we take this value for y and plug it in. It doesn't matter which equation you use, but plug it into one of your original equations. So if I plugged it in back to the second equation, I would have negative 4x plus 2 times y, which is -2, and that equals 6. So negative 4x minus 4 equals 6. Negative 4x plus 4, I'm going to add 4 to each side, equals 10. And divide both sides by -4. And I get x equals -5/2. Now take that x value and that y value and plug it both into the first equation. Plug them both into the first equation and plug them both into the second equation. When you do that, you should get 1 equals 1 and 6 equals 6. So just looking at example 3, you should have solved using the elimination method. So you either eliminated x or y. It really doesn't matter. In this set, it's about the same number of steps anyway. So if you were eliminating your x value, you multiplied the first equation, each term in the first equation by 3, or each term in the second equation by 2. If you were eliminating y, did anybody eliminate y? Okay, well you could have, and if you did, you would have multiplied each term in the first equation by 2 and each term in the second equation by 5. So if you eliminated x and you solved for y, you got 11y equals 22, y equals 2. And then you substituted your y value into either the first or second equation, it doesn't matter which one. And when you solved, you should have gotten x equals -2. Then always verify by plugging those values back into your original equations. You should get 6 equals 6 and 2 equals 2. Remember your graphs from 3.1. If you had infinitely many solutions, your graph was the same line graphed twice. So it was the same linear equation for both lines, and they just overlapped. That means every single point on one line is also a point on the other line. A graph that has no solutions is the two lines are parallel. Okay, so they have the same slope, they will never intersect. That means any solution on one line is not ever going to be a solution on the other line. So this is what the graph looks like for no solutions. If you're not graphing and you're just solving, something with infinitely many solutions would look like 3 equals 3. That is always going to be true. Okay, so if you get x equals x, or y equals y, or 3 equals 3, or 0 equals 0, that will always be true. Whatever x is will still be whatever x is. That means any point here will be on both lines. For no solutions, you'll get something like 3 equals 5. Okay, that will never be true. 3 will never equal 5 no matter what universe you live in. 3 never equals 5. And so this could be an example of no solutions. So let's do example A together, and then you can do example B with a partner or on your own. So looking at the first one, linear system with many or no solutions, solve the linear systems. Are we going to use substitution or elimination? Substitution. What variable are we going to solve for? In the second equation. So rewrite that, 2x minus 3 equals y. And then since you solved for y in the first equation, you take this value and put it back into the first equation. So you get 4x minus 2 times y, which is y is 2x minus 3, and that equals 5. So we get 4x minus 4x plus 6 equals 5. Our positive 4x and negative 4x, but the values cancel out. So we have 6 equals 5. That will never be true. Okay, 6 will never equal 5. Therefore, we have no solution. You could have also solved this. I probably would have used the substitution method like you did, but you could have also solved this using the elimination method. So if you use the elimination method, you could have multiplied the second equation by -2. And you would have got negative 4x plus 2y equals -6. And then 4x and 4x would have canceled out, -2y and 2y would have canceled out. So you would have had 0 equals -6, which also is not true. So you still get the same answer, no solutions, no matter which method you use, either substitution or elimination. Okay, so letter B, try that one with the person next to you. Did you use elimination or substitution? Elimination. Okay, so what did you multiply the first one by? Cassie? Okay. And the second one? 4.
We did negative.
Okay, so it works to multiply by -3 here and multiply by 4 here. Something I often do is if I see like 3, 6, 9, and 4, 8, 12, 4, 8, and 12, those are all factors of 4. You can also multiply by fractions, which is the same as dividing. So you can do that, multiply by -3, and you can do this, multiply by 4. You could also divide this by 4, which is the same as multiplying by 1/4. Or you could divide this by 3, which is multiplying by 1/3. Doesn't matter what you do. If it eliminates the variable, then that's good. It eliminates the variable. But I always, if it's like all of the terms are multiples of the same number, then it's easy to just divide. Okay, but let's do what you did, multiply by -3 and multiply by 4. You got -12x plus 24y equals 36. And you got
I don't think you would multiply by -3.
no, you would not, you're right. You would have to multiply by +3. Because if you multiply by -3, then you would get -12x minus 12x, which would give you -24x, which would not eliminate. So yeah, we have to multiply by +3. Okay, so 12x minus 24y equals -36. And then -12x plus 24y equals 36. So this cancels out, this cancels out, and this cancels out. So we have 0 plus 0 equals 0. That will always be true. So you have infinite solutions. Okay, so for that on your own that you guys did, here are the solutions that you should have gotten. So just make sure that you verify, double check by plugging back into the original.